Here's another freaky fungus, the bug Sputnik. This is the bug Sputnik fungus, and it is a type of Ophiocordyceps, and if you're familiar with cordyceps, you may have an idea of what is happening, but basically, this fungus is parasitizing a scale insect. Scale insects are types of plant bugs that are commonly considered pests in pretty much every area, and these guys, the bug Sputnik, grows on those scale insects and parasitizes them, usually causing death of the host. It is related to the famous zombie ant fungus, which I've talked about a few times before. Now, I did find a couple sources that say the bug Sputnik is native to Canada, however, I was unable to find if it is found anywhere else in the world, but it is, in fact, found in Canada, in the provinces of Ontario and Manitoba. However, other than that, there really is very, very little information about the bug Sputnik. On today's episode of Yeah, That's a Thing That Exists, the jewel wasp, also known as the emerald cockroach wasp. These guys are a type of very small solitary wasp that are native to a few areas in Africa, Asia, and some Pacific islands. Now, jewel wasps are very highly parasitic and have a very, very interesting life cycle. As you may guess from the other name, it does involve cockroaches. Jewel wasps rely on cockroaches as a host for their eggs to grow up in, so the female wasp, after mating, has to go find a cockroach. What happens after she finds a suitable cockroach is she will sting the cockroach in a very specific spot in the head, right in one of the ganglia or brains of the roach. Now, this has many functions. The venom will kind of somewhat paralyze the roach, however not full paralysis. Since this is a rather small wasp, she still needs the roach to be able to move fully on its own. So the sting damages the ganglion and turns off the escape response. Specifically, it messes with the neurotransmitter octopamine. Now, octopamine is very, very similar to norepinephrine and fulfills the same fight or flight function that norepinephrine does in vertebrates, octopamine does in invertebrates. So essentially, the sting from this wasp will turn off the neurotransmitter fight or flight response, making the roach incredibly docile. Next, once the roach is fully subdued, the jewel wasp will chew off half of the antenna of the roach and use those as kind of a leash or lead to pull the roach back to the burrow of the female jewel wasp. Once in the burrow, she will lay her eggs on the outside of the roach by the legs and just kind of seal up the burrow to go find another roach victim and just leave it there. Once the larvae hatch in a couple days, they start to feed on the roach, which really does not give a fuck because the escape response has been fully turned off, so it just kind of sits there in the burrow being fed on by these wasp larvae. The wasp larvae will continue to feed on the roach and grow, and once they reach full size, they will enter the organs and fully consume, thus killing the roach finally, and then transform into the full adult wasps, at which point they will emerge from the burrow and go ahead to mate and continue the circle of life and fucked up cockroach parasitism. Now, fortunately, these guys are not in any way harmful to humans. They have a comparatively mild sting compared to some other types of wasps, and luckily, since we have norepinephrine instead of octopamine, we do not get our fight or flight turned off by a sting from these guys because it doesn't affect our neurotransmitters, as we have very different ones than bugs do. And as a bonus, they take care of roaches, which is usually a good thing. Let's talk about the Humboldt squid. This is the Humboldt squid. It's a relatively large squid species found in the Pacific Ocean around the bottom of Chile and the islands of Tierra del Fuego all the way up to California. However, due to changing climate conditions and the increase of El Niño warming events, they have started to migrate up north and have been found up as far as British Columbia and Alaska. Now, like I said before, these guys are quite large, not giant or colossal squid large, but still quite large, with a body length, not including tentacles, of up to 6 feet long, and including tentacles much, much larger than that. They're also quite social, usually spending the majority of their time in a large group of other Humboldt squid, sometimes over 1,000 individuals in the same group. They're also highly predatory and incredibly carnivorous, eating pretty much anything they can get their beaks and tentacles on, be that small fish, crustaceans, jellyfish, or even other squid. Even still, other Humboldt squid. They have been observed to be quite voracious cannibals, eating each other, sometimes even still alive. If there is a sick or injured squid, the others will just attack and eat it. Now, most of the time they are relatively deep-sea animals, spending most of the daytime around 200 to 700 meters below the surface. However, during the night to feed, they do come up to the surface to feed. Again, most of the time in these quite large and very, very aggressive groups. They are aggressive towards each other, aggressive towards other fish, and even towards humans. There's been multiple recorded attacks of Humboldt squid on humans. That is largely during feeding time, so if somebody is in the water with all of these Humboldt squid during feeding time, they are quite likely to be attacked. Like many other cephalopod species, the Humboldt squid are capable of changing colors due to different color cells within their skin. Additionally, they are capable of creating bioluminescence, so during those large feeding frenzies, they do typically glow a bluish, greenish, yellowish color. So, aggressive and cannibalistic they may be, they are still quite interesting animals and are probably my favorite squid species. Let's talk about snotite. Now, you may be thinking, hey, that sounds kind of gross, and rest assured, it absolutely is. This is snotite. It is kind of similar to a stalactite in that it drips down from the ceiling of caves. However, unlike stalactites and stalagmites, snotite is technically alive. Because all of this is actually a very specific type of extremophile cave bacteria. Basically what this is a bacterial biofilm, which is just this large mass of bacteria kind of contained as a community in some sort of matrix. Now, a more common example of a biofilm is the dental plaque that you get on your teeth. But this is also a biofilm which allows these bacteria to live in very harsh cave systems. Now this down here is also snotite, but it is the dripped down snotite that has fallen off of the roof of the cave and is now instead pooling on the floor. Now these bacteria live deep in caves with zero sunlight and pretty much zero nutrients, so they have to survive by a process of chemosynthesis, which is sort of like photosynthesis, but instead of using the energy from the sun, you use an energy from chemical reactions. In specific, these guys metabolize the very abundant hydrogen sulfide which is found deep within these caves. They metabolize it, and the output, the waste products, typically are things like sulfuric acid, which is a very strong acid. So the very acidic output also adds to the extremeness of the environment that these guys live in. Now, snotites were first discovered in a cave in Mexico, the Cueva de Villaluz. Let me know if I'm pronouncing that correctly. But what's interesting about the snotites in this cave is that they are the very base of an entire ecosystem. The snotites form at the top of the cave, but then they drip down, and instead of just falling and pooling on the floor of the cave like in the last image, they fall into some very hot and acidic pools, which somehow sustain fish. These cave fish will eat these snotites that fall in, and that is basically what sustains them. Now, there's not a whole lot of other things happening in the cave. It is largely bacteria, water, fish, and sulfur, which does not make a very inviting environment. However, it does make an incredibly unique ecosystem that is pretty much found nowhere else on Earth. And by examining these weird organisms and ecosystems, it actually may provide some evidence of what life might be like on other planets with similarly weird and extreme conditions. Happy Friday the 13th, let's talk about bloodletting. Now, I'm sure many people, at least in passing, are aware of the process of bloodletting. It was used throughout most of human history, or at least recorded history, all the way back from the ancient Egyptians and ancient Greeks up until about the 19th century. Now, it was used in order to treat a multitude of different things, including illnesses and headaches and fevers and just kind of anything. It was like, you got too much blood, let's get some of it out. Now, the kind of logic behind bloodletting was based on humoral therapy, popularized by the physician Galen, where the body was made up of 4 different humors: black bile, yellow bile, phlegm, and blood. The idea was that humans had to have all 4 humors in an equal balance throughout the body, and if you had too much or too little of one or more humors, that's when problems started. So bloodletting was done in order to reduce the amount of blood, one of the humors, because it was thought that certain disorders were caused by having too much blood, so you had to get some out. Then, hopefully, the humors would be put back into balance, and whatever affliction was ailing that person whom the bloodletting was done to would go back to regular health. Now, bloodletting was done by kind of 2 main processes, either by venesection, or the opening of the veins, or by using leeches. Either way, the leeches or the venesection would cause the blood to be removed from the patient and reduce the humor of blood. Now, I've talked about this slightly before, but leeches are actually still used today in a couple very specific medical contexts. They help with preventing tissue death after surgery, with preventing blood clots, and helping the regrowth of veins and other blood vessels after they've been severed or other stuff. So leeches are actually still used today, which I just think is very cool. There are medical grade leeches that have been kind of sterilized to prevent any bacteria or viruses getting in, but that's kind of aside the point. I just really like leeches. I'm a big fan of these guys. Now, in modern times, bloodletting is not used at all in a medical context. In some traditional medicine or alternative medicine, it is still being used, but it is almost entirely accepted as ineffectual. In most cases, it would actually make the patients worse by opening the door for other infections through an open wound, or in the case of leeches, a animal-borne illness into the blood of an already not at peak performance individual. You also need your blood. Blood is very important. It transports nutrients, it transports oxygen, it does a lot of things. So by reducing the amount of blood in your body, especially during illness or other afflictions, it's generally not a super okie dokie thing to do. Now, back when bloodletting was popular, illnesses and broken bones and cancers and everything had a very, very, very low survival rate, and bloodletting decreased that survival rate by a lot. Most individuals who had bloodletting as a treatment later died, unsurprisingly. One famous example of this is the first president of the United States, George Washington, was thought to have died due to over bloodletting. Like, man was kind of bled to death by his physicians, and he died from bloodletting caused by a very survivable illness. And in the early 1800s, there were a lot of studies done by physicians being like, hey, maybe draining our patients of all of their blood actually isn't helping, because by that time, germ theory was becoming a little bit more well known, the humoral theory was gradually losing popularity, and people are like, hey, why are we trying to still balance humors when we don't really think that's how the body works anymore? So, numerous studies were done and found that people who had their blood let during illness actually had a much lower survival rate than people who did not have their blood drained out of their body. After these studies, bloodletting pretty much entirely fell out of practice, and just again as a side note, this does not the same thing as using leeches medically. That's a different context. This is also not the same thing as like donating blood or phlebotomy or blood test or anything. Those are entirely valid reasons to remove blood from the body, and are also not done at the scale that traditional bloodletting was done. Donating blood, you keep most of your blood, and you only give away a small portion of it. Same thing with getting a blood test done, you're not having all of your blood removed. So while it is a very interesting part of medical history and all of that, it is definitely a very good thing that bloodletting is no longer practiced, because it did not work. We've talked about the junk bug before, now let's talk about its spiritual successor, the bone collector caterpillar. The bone collectors are a newly discovered species of caterpillars only found on the island of Oahu. They're the caterpillars of a specific species of moth, and as you may guess, they have some very, very interesting adaptations as a caterpillar. It is an incredibly carnivorous caterpillar, and this spiky shit up there is the corpses of its victims. After it eats something, it will dismember it and put it on its back to act as camouflage. Now, camouflage against what? Camouflage against spiders, because the bone collector caterpillars live in and amongst spider webs that are actively being used by one of the caterpillar's main predators, the spiders. That's right, the bone collector caterpillar will hide disguised in the web of its enemy, wearing the dismembered corpses of both the caterpillar's victims and the spider's victims. Both the food source and the decorations for the caterpillars comes from the webs itself. When another insect gets stuck in the spider's web, it will either be eaten by the spider or the caterpillar. At which point, after the insect has been sucked dry by the spider or consumed by the caterpillar will take up the body parts and add it to the graveyard of decorations. The caterpillars have sometimes even been known to unwrap the silk cocoons that the spider has left after the spider has finished eating, and then adding that to its back. This over here also is the adult moth that this monstrosity will eventually turn into. Now, it's somewhat rare to see the caterpillars actually be predated by the spiders because their camouflage is so very good. The spider's just like, oh yeah, dead body. These little guys will eat pretty much anything that they can get, including things much bigger than them, and they will add pretty much anything to their casing, including shed spider exoskeletons of the spider that they're sharing the web with. And they've also, in a laboratory setting, when scientists collected them to study, have been known to exhibit cannibalism. They will eat each other if presented with the opportunity. Now, since these guys are so rare, they're found only on a small part of one singular island, they are considered to be endangered now and are at risk from many things, including habitat loss and degradation and predation by invasive species, and a whole lot of other things. So, while they are incredibly fascinating, they are unfortunately at risk. On today's episode of Yeah, That's a Thing That Exists, the Melibae viridis, which is probably not how you pronounce that scientific name. Melibae viridis is this funky lad up here, which happens to be a member of the nudibranch family. Nudibranchs are basically just sea slugs that are found in pretty much every area of the ocean. These guys in specific are found in the Red Sea, the Mediterranean Sea, and a couple select areas of the Indian Ocean. And they are carnivorous and have quite an interesting method of feeding. That up there is its mouth, which it is capable of kind of extending and ballooning out in a manner similar to a fishing net. It kind of just hangs out with its mouth extended out like that until something lands on it, at which point it will contract into kind of a more bulbous shape like that, where it will trap its food, at which point tentacles will kind of sweep it into the rest of its system, where it will then be digested. Now, fortunately, this eldritch monstrosity of a sea slug is quite small, only reaching about 5 or so inches. Not nearly large enough to cause any damage to people beyond psychological damage. And as far as I am aware, unlike other types of sea slugs, these guys are non-venomous, so we really have nothing to fear, unless, of course, you are a small planktonic animal that gets caught in the weird fishing net of a mouth and then digested. Alrighty, since my chimney swifts video is blowing up and everybody is very concerned about the airborne spiders, let's talk about ballooning. Now, ballooning is a behavior that's not exclusive to spiders. It's also seen in other invertebrates such as caterpillars and mites, but we'll talk about the airborne spiders. Ballooning is a type of dispersal behavior, seen where a type of invertebrate, largely spiders, but again not exclusively, releases silk threads up into the air. These silk threads get caught by usually airwaves, but also the Earth's electromagnetic field, because that's a whole thing that we don't need to go into, but basically those silk threads get caught up and drag whatever produced it, namely the spider, with it. Now, most of the time this is used by spiderlings or newly hatched spiders in order to kind of disperse out away from their siblings to find new territory to live in away from competition. This works especially well since these spiderlings are usually incredibly small and incredibly light, so they can get great distances with little difficulty. Now, most of the time this dispersal distance achieved by ballooning is quite small, usually a couple meters, but depending on the species and the weather conditions and everything, they can get quite far away. There's been reports by sailors and other seafarers in the middle of nowhere in the ocean being landed upon by spiders. So sometimes travel of multiple hundreds of kilometers can be achieved by ballooning, depending again on the individual spiders and the weather conditions. And this makes them a very good source of food for, namely, birds, such as the chimney swifts in the video that is currently blowing up. Flying birds will just take a snatch of a spider or caterpillar or whatever have you out of the air and take a to-go meal. Now, there are usually distinct ballooning seasons between late spring, early summer, sometimes even into autumn, where many spiders will disperse all at once, typically leaving a large amount of silk behind them. This will cover trees, power lines, grass, houses, all of that in this spider silk, left behind by these little airborne spiders just going up and away. Now, the silk itself might be a little bit annoying, but it is harmless. It's just kind of left behind junk that most of the time doesn't have any spiders in it. As far as the spiders themselves, as far as I'm aware, the majority of the species that exhibit ballooning behaviors are not dangerous. Most of the species that do the ballooning belong to the orb weavers, the wolf spiders, or the crab spiders, most of which cannot hurt humans, especially at the very, very small and early stage in the life cycle where they're small enough to be able to be picked up and ballooned. So you don't have to worry about getting rained upon by, like, black widow spiders or tarantulas or anything like that. Most of the species are very small and very harmless. But yes, as a clarification for all of the people in the comments in the Chimney Swift video, this is what I mean by airborne spiders. Hope you enjoy. Let's talk about vampire stars. Vampire stars are a very similar concept to how they sound. It is one star basically siphoning off stuff from a neighboring star in kind of a binary system. This occurs when the two neighboring stars have quite a large difference in gravitational pull. The star with the larger gravity will start to siphon off things, be that plasma or actual material, from the neighboring lower gravity star. Now, this is vaguely similar also to the cannibal galaxies that I've talked about before, where one galaxy will essentially absorb and eat the other. The vampire stars are similar, that one will just kind of siphon junk from the one beside it. Now, there was one instance of this observed somewhat recently by the Kepler telescope, where there was a white dwarf star and a brown dwarf star in close proximity, and the higher gravity white dwarf was siphoning stuff from the lower gravity brown dwarf. This is not the actual images, this is kind of an artistic rendition of that to show it a bit more explicitly, but kind of what is happening, the white dwarf up here is pulling stuff away from the brown dwarf and forming what is called an accretion disk. The accretion disk is basically a disk swirling around the white dwarf made from all of the stuff that the white dwarf sucked away from the brown dwarf. What a white dwarf star is essentially a star kind of leaning towards the end of its life cycle after it exhausted all of its kind of resources and fuel to burn up. A brown dwarf is also called a failed star, where it has a large enough mass to not be considered a gas planet, but not enough to ignite and be an actual real star. The brown dwarf has a lower mass and gravity, which is why the white dwarf is able to siphon off a bunch of stuff from it because of its higher gravitational pull. Since the white dwarf is generally at the end of its life cycle or nearing the end, it is a rather old star. However, during the vampire star kind of event, since it's kind of absorbing so many things from the neighboring brown dwarf, it actually burns quite a lot brighter and gets the appearance of a much younger star that's not close to the end of its life cycle. After the kind of vampire event is done and the accretion disk has kind of been resolved, it is now called a blue straggler star instead of the white dwarf star, meaning that the star appears to be a lot brighter and also bluer tinted than theoretically it should be, going off of its age and stage in the life cycle. So overall, the name of the vampire stars are really quite fitting because essentially that's what is happening. There's a binary star system, one star has a much higher gravitational pull than the other, and so siphons off the matter and lifeblood of the lesser gravity star, incorporating it into its own and appearing a lot younger than it actually is.